theorem, the ratio test. Suppose we have a series and suppose that we calculate the limit as an approaching infinity of n plus 1 divided by n ratio, and we take absolute value and say that limit equal exists and equals rho. And the conclusion is going to be the following. Then the infinite series is we're going to have three possibilities. It's going to be convergent absolutely. Absolutely. If rho is small, if rho is less than 1. Second case, we have our series is going to be divergent when rho is big, if rho is bigger than 1. In the third case, inconclusive, we cannot say whenever series is convergent divergent, then the rho is exactly 1. So we have three possibilities. So let me give you an idea why that works. Idea. If limit of n plus 1 divided by n, absolute value, when n is approaching infinity, equals to rho, and then for big, huge n, which usually mean n bigger than capital N, an plus 1 over an, and I'm going to put absolute values here. It's going to be approximately equals to rho. And you see what is going on here, because ratio of consecutive terms equals to rho, that will be similar to geometric series where the ratio is going to be rho. Okay, so that series consisting of absolute values, and we start. So that series which consists of absolute values and we start if capital N go to infinity will be similar to series where n starts at n to infinity a r to n, something like that. So it's going to be similar to geometric series if r equals to rho, and you remember the conclusion about geometric series. If r bigger than 1, then it's divergent. If r between 0 and 1, it's going to be convergent, and that's exactly what is going on here. So let me try to do an example or two related to that, related to our ratio test. First example, series n divided by 2 to n, and from 1 to infinity, and we have our regular equation. We want to determine whether a series is convergent or divergent. We certainly could have done this problem by doing comparison test. Let's try working on it using ratio test. So we want to do ratio test. We want to do ratio test. So rho is going to be equal to limit as n approaching infinity. We take the next term, so we substitute n plus 1 for n, and we dividing it or multiplying by a reciprocal of n. And reciprocal of n is going to be, we're going to flip it. Okay, so visualize it. That guy here is n plus 1. The guy right here is 1 divided by n, so reciprocal. Okay, and if needed, take the absolute value of that, but we don't need to do the absolute value here because all expressions are positive. So we're going to get 2 to n times n plus 1 divided by 2 to n plus 1 over n. These two guys will be reduced into 1/2. To work with these two guys, you either do rule of thumb or you can do L'Hopital rule. If you do, for example, rule of thumb, we're going to get limit as n approaching infinity. As I mentioned already, 2 to n over 2 to n plus 1 using algebra, it's 1/2. Higher power dominates, rule of thumb, so n plus 1 is good as n. Now simplify, we're going to get 1/2, so we're going to get rho equals to 1/2. Rho is less than 1, so we conclude that our original series is convergent or absolutely convergent by the ratio test. So that's the first one. Let's try another one. Let's do another example. We have a series, -1 to n, multiplied by n squared, divided by 3 to n, and we want to know whenever that series is convergent or divergent. So let's try. So again, we're going to be doing a ratio test. So we're going to find rho. So it's going to be limit. So n approaching infinity. An plus 1 will become -1 to n plus 1, n plus 1 squared over 3 to n plus 1. That is an plus 1. Then we're going to write down the reciprocal of an, which is going to be 3 to n divided by -1 to n and n squared. And then we're going to take absolute value of that. Okay. Because we're taking absolute value of that, we can take care of it -1 to n plus 1 and -1 to n, because absolute values of those becomes just ones and multiplied by 1 will just disappear. I will also do rule of thumb. Okay, so n plus 1 squared is as good as n squared, high power dominates. 3 to n divided by 3 to n plus 1 multiplied by n squared. That's what we've got. Do some algebra here. So we should be able to get at the end 1/3. So we're going to get rho equals to 1/3. So we conclude, because rho is less than 1, their original series, -1 to n squared divided by 3 to n, and from 1 to infinity is absolutely convergent and particularly convergent too. Before we move on to the next example, let me give a definition of factorial. So 1 factorial is 1, 2 factorial is 1 times 2 is 2, 3 factorial is 1 times 2 times 3 is 6, 4 factorial is 1 times 2 times 3 times 4 is 24, 5 factorial is 1 times 2 times 3 times 4 times 5 is 120. So you got an idea. So n factorial in general is going to be product all the integers up to that n. We often will need to do simplifications with factorials. So for example, n plus 1 factorial, and I want to simplify it with n factorial. N factorial is product over integers up to n plus 1 factorial is product over integers up to n plus 1. You see how nice cancellation will go. So we're going to have n plus 1. In a similar fashion, n factorial over n plus 1 factorial is going to be 1 divided by n plus 1. Okay, just keep that in mind. We often use the ratio test. Then we have infinite series, and we have infinite series where we're going to have a factorial sign. Okay, something like we have here. So infinite series, n from 1 to infinity, negative 1 to n, multiplied by n factorial, divided by 3 to n. So we have the same equation, our regular equation whenever the series converges to divergent. So let's try. So we're going to do the ratio test. I'm going to rho equals limit as n approaching infinity, negative 1 to n plus 1 n plus 1 factorial divided by 3n plus 1, that is n plus 1, reciprocal of n, so 3n on top, negative 1 to n and factorial. Take absolute value of that expression. Absolute value of that expression will take care of negative 1 to n plus 1 and negative 1 to n. That will become just 1. That will become just 1 when taking absolute values. So we're going to get n plus 1 factorial multiplied by 3 to n divided by 3 to n plus 1 divided by n factorial. So I probably will rewrite it one more time. Similar with similar. So I'm going to write down 3 to n over 3 to n plus 1 and n plus 1 factorial divided by n factorial and times in between. Using simple algebra with the first ratio, we're going to get 1/3. We already discussed what is n plus 1 factorial over n factorial is going to be equal to. That is going to be n. So we're going to get limit as n approaching infinity n divided by 3. So we're going to get infinity divided by 3. So final answer is infinity. So we got rho equals to infinity. Infinity is definitely bigger than 1. So we conclude that the original series negative 1 to n factorial divided by 3 to n and from 1 to infinity is divergent by the ratio test.